Good morning, everybody. Welcome to everyone. Thank you for joining us this marine energy webinar session. Marine energy meets conservation. My name is Peter Davies. I'm chairing the session this morning. I chair Wales Council for Voluntary Action, but I also chair the Wales Marine Action and Advisory Group, and have a long background in sustainable development, including as the Commissioner for Sustainable Futures in helping to develop the Wellbeing of Future Generations Act here in Wales. But Marine Energy Wales have asked me to chair this webinar today as somebody who's independent of the sector, but obviously a strong interest and background in terms of sustainable development and also the marine environment in Wales. We've brought together experts in marine renewable energy and conservation to have an open discussion of how this emerging industry interacts with the environment and what needs to be done better to understand that interaction. It leads on from Wales Climate Week, a really successful week of interactions on climate change and the response to climate change. We all know there's a climate emergency and the importance of taking action to tackle this. And we all know, I think, that our oceans provide a key source of sustainable energy, and marine renewable technology looks to harness this power and make a significant contribution to addressing the climate emergency. But as a new industry, there are obviously some concerns as to what impact this technology might bring. And it's important to recognize that as well as the climate emergency, we also have very much a nature emergency. And so we must ensure that those two emergencies are tackled in tandem and don't impact on each other negatively. So today we're going to be exploring this topic and to see what we can do to achieve the balance of needs of conservation and an emerging sector in marine renewables in developing that green recovery for Wales. I should also add that I sit on the Green Recovery task group for Wales, chaired by Sir David Henshaw, the chair of Natural Resources Wales, and marine renewables and marine conservation and the blue recovery has been a key theme of those discussions. Today, I'm sure we'll have a really valuable session. We may not come up with the answers and solutions and conclusions in this webinar alone, but it's going to be a great opportunity to highlight the work being done to improve our understanding, the knowledge sharing, the collaboration in this area, and to have an open floor for discussion. So joining me on the panel today, we have Jess Hooper, Marine Energy Wales. I'm sure panelists, you can see the panelists online. I think they can give a wave as I introduce their names. James Moon from Natural Resources Wales, Jennifer Fox from the Offshore Renewables Joint Industry Programme, Aly McCluskie from RSPB, Carol Sparling, the Sea Mammal Research Unit at the University of St Andrews, and joining us at 11 o'clock, so not online at this moment, is Paul Ellsmore from Marine Energy Engineering Centre of Excellence. We'll shortly hear from those panelists, and then we'll be holding a Q&A session. So please submit your questions as we go through the presentations via the Q&A button along the bottom of your screen. Submit those questions as we go along, and I'll do what I can then to perhaps group those questions into themes and tackle those themes with the panelists at the end of the presentation. We're not going to be focusing on specific projects in the course of this discussion, and so I'm going to ask if questions can be posed generally and generically rather than necessarily focus on specific project cases. The chat option also available for general commentary or if you need any assistance, and Beth is on hand with any technical difficulties as well. So that's enough from me as an introduction to what I'm sure will be a really valuable session that will draw to a close at 12 o'clock. So let's begin with Jess Hooper, Jess from Marine Energy Wales with the first presentation. Let's welcome Jess.
Diolch. Thank you, Peter. Shwmae, bore da pawb. Good morning, everybody. Can someone just confirm that you can see my screen with a nod? Yeah, I've got a thumbs up. Excellent. Oh, how do I get that to disappear? There we go. Thank you for joining us this morning. My name is Jess and I'm here today with my fellow panellists to talk you through how projects in Wales seek permission to install marine renewable energy devices. We'll talk through the process, some of the challenges, and how industry experts are coming together to try to overcome some of the uncertainties we face in our protected Welsh waters as we work to harness the immense power of our seas to make our contribution to net zero and decarbonise our energy supplies by 2050. So what is marine renewable energy? Did you know that in the UK, we're leading the world in understanding how we can use the ocean's natural rhythms to produce clean, sustainable electricity from marine renewable energy, which will enable us to take action on climate change and reduce our carbon emissions. And as world leaders, this sector is also helping us to deliver a resilient, low carbon economy with its own jobs, skills and prospects, and is an industry that we can currently call homegrown, that we could export to the world. So how do we do this? A number of methods and technologies exist to harness the power of the sea. Firstly, we have tidal current or stream, where kinetic energy, which comes from the movement of water when the ebb and flow of the tide is forced around islands and into estuaries, and therefore accelerates, creates a predictable energy source twice a day, which is used to drive turbines, which might float on the surface or could be attached to the seabed or even fly underwater kites. We also have tidal range, which is the increase in height of the ocean caused by the ebb and flow of the tide. We can capture this change in height using lagoons or barrages, which have turbines installed in their walls. Then there's wave. Waves act like a store of wind energy. As the wind passes over the sea, energy is transferred from the air to the water. Wave energy then arrives at our coastlines later than the wind energy did. There are lots of ideas for technologies to capture wave power, from floating devices, devices below the surface or on the seabed, such as those shown as in this image here. Then we have floating offshore wind. With Wales's deep water, it could be very expensive to create structures tall enough to sit on some of our seabed. However, with recent progress, engineers have found ways that these turbines can float on platforms, which means we can look to install these devices in the Irish and Celtic Sea, further from shore. We're incredibly lucky here in Wales to have all these resources on our doorstep. As you can see from this map, with purple for tidal stream, orange for wave and blue for wind, with up to 50 gigawatts more not shown here in the Celtic Sea, which is the sea between Wales, Ireland and Cornwall. In order to harness these forms of renewable energy, we also need electricity cables to export the power and ports to build and transport the devices, also illustrated here and present in Wales. So why is Wales somewhere to be talking about marine renewable energy? Access to energy is fundamental for modern society. It underpins much of our daily lives, from the buildings we live in, the way we cook dinner or make a cup of tea, the transport we rely on, the leisure activities we enjoy, to the way you're watching this webinar today. There's a growing awareness that our existing energy sources are finite and are having a negative impact on the climate. Marine renewable energy can make a significant contribution to addressing these issues. It also aligns with goals from the UN and more locally with our own well-being of future generations goals. Crucially, it also brings economic development and the associated jobs to our coastal communities, helping to create sustainable and resilient levelling up across the UK. We're currently global leaders in this sector, and here in Wales we have a number of amazing projects already underway, as you can see from this map, with 16 developers, 4 test sites and 2 alliances, all clustered around our coastal regions. However, there are some concerns about how our treasured Welsh wildlife might be affected by these projects. Welsh waters are widely recognised as being important, with 37% of the marine environment and 75% of the coastline protected through European legislation. This legislation, highlighted in greater detail by my NRW colleague James shortly, puts in place a rigorous process to ensure checks and balances are in place, so the environmental impact does not outweigh the benefits these technologies can bring. Some of the most common concerns that we hear. Firstly, there shouldn't be a trade-off between conservation and climate mitigation. I think it's fair to say that the longer climate change continues, the more impact on biodiversity we will see. And so climate mitigation is a crucial action we need to take now. But equally, ensuring limited impacts on biodiversity is key. Marine Renewables looks to make a significant contribution to addressing the climate emergency by decarbonising our energy supplies. From a personal point of view, I'd also say people working in this sector are passionate about our planet, And the reason they work here is to do their bit. Then there are concerns around the untested nature of the technology. There has been some significant testing of marine renewable devices already, with some testing carried out in Wales, but with lots more devices that have been tested in Scottish waters, with thousands of hours worth of testing recorded. As an industry, we're working to be as collaborative as possible and share lessons learned from this testing. However, we're still in early stages of this industry, and there will be further testing to do before we reach commercialisation, which is why we see the 4 test and demonstration sites I mentioned previously in our Welsh waters to run largely by non-commercial enterprises, such as our very own Marine Energy Test Area. Then there's uncertainty around the level or quality of monitoring and how monitoring results will feed back into decision making. My fellow panelists will cover this aspect in more detail than I can, but for those not familiar, there are conditions put on marine licenses for monitoring of devices once they're in the water. And you could be forgiven for thinking that we were in Scotland in a moment, with good reason though. When I mentioned previously that the UK is leading the world in this sector, we can currently credit a lot of the past activity and installations to Scotland, consented under the Scottish consenting regime. This means there's a wealth of knowledge in Scotland that we here in Wales can learn from, benefit from, and use to inform our research, our design work, and our decision-making when installing projects in Welsh waters. We're working closely with NRW and environmental NGOs as part of the Consenting Strategic Advisory Group to review best practices and standards for this. Furthermore, the Welsh Government has just recently commissioned Swansea University to undertake a desk-based review of the monitoring methodologies and technologies suitable for deployment in high energy environments in Wales, with the aim of closing an evidence gap specifically relating to the potential for collision risks between marine animals and marine renewable devices. Then there's uncertainty over the level of risk to wildlife. James will elaborate on this further in his presentation, but all projects have to go through a robust consenting process. As part of this, an environmental impact assessment is carried out, which includes studies of wildlife in the area, such as birds and mammals, to get a thorough understanding of existing activity, wildlife activity in the proposed area, before assessing any potential interactions. James will explain this regulatory process, but there are also lots of supporting research projects being undertaken to try to understand this further, and my fellow panelists will be going into further detail on this. Then there's concerns around deployments of devices in sensitive areas. For tidal and wave energy to be cost competitive, these devices need to be deployed in areas of peak resource. It's often the case that the areas of high tidal flow are in the same areas as conservation sites, largely given the prominence of Welsh waters being protected. It's not a matter that we seek to put devices in these areas where there is wildlife, but that these areas offer the best resource. However, we should also note in Welsh waters, we have companies such as Monesto that are looking to deploy in low flow areas that are beyond the high resource areas identified in the previous map. We need, as I mentioned previously, we need to try to learn from other projects that have been installed in those high resource areas, how we can deploy in our own areas with the least impact possible. To summarise, this is a nascent industry with associated unknowns. We've seen very few deployments in Welsh waters. These unknowns lead to uncertainty and a perceived risk associated with deployments. However, there are devices in the water elsewhere that we can learn from. We do need to consider what we do know already from an environmental point of view. Now, we won't be seeking to address these concerns outright today. We want to demonstrate to you how, as a sector, we're working to better understand these concerns, how we can explore them, how we can monitor nature's response to the presence of these technologies in the water. Some work has already been done. There's no question that there is more to do. So today we've brought together a number of experts who've been working to understand the interface between this sector and the environment. In line with the well-being of future generations goals, there's a strong driver for collaborative working, seeking solutions that are robust, resilient and responsible. Already in marine renewables in Wales, we see Welsh Government, the regulator Natural Resources Wales and the sector seeking a collaborative approach to support Welsh Government priorities and interest areas, whilst taking into consideration those concerns for the environment arising from the perceived risks of this technology. Ultimately, we need to enable the sustainable management of our natural resources. Also today, as part of this webinar, we kick off an offshore renewable energy innovation challenge. You'll hear now from my colleagues of the progress to date, the gaps in understanding and what we need to do next as we seek to decarbonise Wales's energy needs in a sustainable way. James will now talk you through the regulatory considerations that interrogate development projects in the sector before they are able to proceed. Over to you, James.
Thank you, Jess. That was a really good setup for this session. And a good introduction to James leads on neatly. Thank you, James.
Can you see my screen, Peter?
Yeah, good. You'll need to go into presenting mode, but yeah, got it. Good.
How's that?
You're there.
Okay. Hi, everybody. So thanks very much to Marine Energy Wales for allowing me to come and speak to you all today. I'm going to provide a bit of an overview of the consenting process in Wales. I'm the Offshore Renewable Energy Programme Manager for NRW, so obviously the work in Marine Energy Wales has quite a lot to do with us, and we're trying to work closely with MEW and other stakeholders to address some of these issues. Firstly, I'm going to provide a bit of an overview of the consenting process in Wales from a marine renewable energy point of view. And I'm going to focus a little bit on some of the key consents, including the Section 36 development consent order under the Planning Act, and marine licensing that is consented via NRW. A summary of the key legislation that we work with, and also a page on some useful guidance that we already have available to help you through the process. So the consenting process in Wales is a complex topic and involves multiple legislative regimes and regulators. NRW is one of a number of regulators that may be involved in consenting a development. So these tables above are taken from an infographic, which has recently been produced by Welsh Government. The small image on the right-hand side is that, but unfortunately it's not on the website yet, but as soon as it's available, it'll be shared more widely. I'm going to provide a little bit more detail on each of these consents in the next few slides, but essentially in summary, for smaller developments below 350 megawatts, a marine license is required from NRW. In addition, a Section 36 under the Electricity Act is required from Welsh ministers. For larger projects over 350 megawatts, a development consent order is required from the Planning Inspectorate. In offshore waters, a marine license may be deemed as part of the development consent order process. However, in Welsh inshore waters, this is not the case, and the marine license is again required from NRW. Not listed here is also the requirement for terrestrial planning consents for cable infrastructure, substations, or any ancillary works. I haven't listed any of those here. I'm just going to cover the marine side of things. Having one type of permission doesn't usually absolve a developer from the need to have others. So when applying for a marine renewable energy project in Wales, you have to consider all of the consents applicable. So now I'm going to delve into the detail of these consents a little bit more. So in 2017, the Wales Act devolved energy consenting power to Wales and increased the maximum megawatt capacity to 350 megawatt, up from 100 megawatt previously. The tables on the left are taken from a Welsh Assembly briefing on the Wales Act and show the previous regime versus the current. Essentially, consent decisions for projects up to 350 megawatts are now made solely in Wales. For test devices below 1 megawatt, no Section 36 is required and just a marine license. So that covers the smaller sort of prototype and demonstration projects that marine energy may deploy. An EIA may also be required for a Section 36, and this must cover the generating station or device and any associated cabling. This same environmental impact assessment is often used to inform the marine license application as well. And where an EIA is required for Section 36, Welsh Government may actually defer the EIA to the NRW Marine Licensing Team for an EIA decision, which has been done on a number of projects to date. However, to be certain, the actual Section 36 decision remains with Welsh ministers. So as I said at the beginning, a development consent order is required for projects over 350 megawatts. So I appreciate the wave and tidal sector may not be at this stage at present, but with tidal lagoons and floating offshore wind potentially in a pipeline, I thought it might be useful to cover at this stage. So nationally significant infrastructure projects are what is known as projects over 350 megawatts, and they require development consent from the Planning Inspectorate under the Planning Act 2008. So Planning Inspectorate, or PINS as it's known, examines the application and will make a recommendation to the Secretary of State, who will make a final decision on whether to grant or refuse a consent. There's quite a strict process and timeline in place for DCO applications, which is shown by this sort of this diagram here. This was taken directly from the PINS website and covers the 6 stages of the process. As you can see, the process provides multiple opportunities for interested parties to have their say at pre-application, pre-examination stages, and the inspector may also deem it appropriate to have a public hearing if there are contentious issues that need to be addressed, and at which point interested parties can also provide input. I've also provided a link there to the Planning Inspectorate website, where there's lots of useful guidance and information available to take you through the process. So now that I've covered the sort of wider consenting regimes, I'll now focus on NRW's role in marine licensing. The Welsh Ministers are the licensing authority under Part 4 of the Marine and Coastal Access Act 2009. But NRW is responsible for the administration and determination of marine licenses, acting on behalf of Welsh ministers. So in broad terms, a marine license is required if one or more of the activities listed here are to be undertaken in the marine licensable area. So this includes deposit and removals in the sea or on or under the seabed using a vehicle or vessel, construction, alteration or improvement in, on, under or over the sea, as well as use of explosives and marine dredging. The map on the right-hand side shows the marine licensable area since changes came into force in 2018 under the Wales Act. And essentially, the marine licensable area now includes the Welsh offshore area out to the median line. So this slide provides an overview of how marine licenses are determined and what the process looks like. In short, licenses are determined regarding the need to protect the environment, protect human health, prevent its interference with legitimate uses of the sea, and any other matters considered relevant. The decision process itself is not dissimilar to the other consenting regimes I spoke about, including the pre-application, application, assessment, consultation, determination, and post-consent. And the post-consent is where the discharge of conditions occurs in terms of monitoring conditions to ensure that environmental impacts are monitored and mitigated if necessary. So that's quite a key part of the post-consent. I've also provided the list of consultees that you can, so you can see the broad spectrum of interested parties. As you can see, NRW are also a consultee as statutory nature conservation body for Wales. So essentially, NRW technical specialists provide advice on environmental matters to the marine licensing team on all applications. And these two roles are actually functionally separate in NRW structure, so that we have clear boundaries between one side as the advisor and the other side as the regulator. In case you're wondering about the colour scheme on the consultees, green it refers to the environmental consultees, grey is the planning or policy consultees, blue includes the users of the sea, and red is the navigational safety. For the greeny blue colour includes other factors such as archaeology and the Crown Estate as leaseholder, as seabed leaser, and then also the public also can have their say on any marine licence application. Okay, so with all regulatory regimes, there is a suite of relevant legislation that must be considered when reaching a determination. This slide is also hot off the press from Welsh Government, and it's an infographic that they've put together which provides a summary of the key pieces of legislation relevant to marine licence determination in Wales. As I said earlier, these infographics will be published on the Welsh Government website shortly, and we'll share those links when they're available. As part of any application, there are three key pieces of legislation that need to be considered and actually require additional technical assessments alongside a standard application. These are shown on the left-hand side, and they include the environmental impact regulations under the Marine Works regs, habitats regulations, which I'm going to go into a bit more shortly, as well as the Water Framework Directive, which also requires a compliance assessment. In addition, the regulator must also act in accordance with legislation on the right-hand side, which do not require additional technical assessments. And this includes the Welsh National Marine Plan policies, which fall under the Marine and Coastal Access Act 2009. The Wellbeing of Future Generations Act, which Jess mentioned briefly a moment ago, but this covers the sustainable development and well-being goals for Wales. The Environment Wales Act, which covers the sustainable management of natural resources and which NRW have a key remit in. And finally, the Wildlife and Countryside Act, which covers sites of special scientific interest. For the Wildlife and Countryside Acts and SSSIs, although they may not be relevant for the offshore waters, they do come into consideration with the sort of cable landfalls and other associated works on the coast. So it's worth bearing that in mind. Okay, so now I'm going to focus a little bit more in detail on the environmental impact regulations and then the habitats regulations. NRW's marine licensing team are the relevant authority responsible for issuing EIA consent decisions under the Marine Works regulations. In order to determine if an EIA is required for a development, an applicant may request a screening opinion from the licensing authority. The EIA regs determine that EIA development means a development which is either a Schedule A1 development, which includes the larger infrastructure projects like power stations or I don't know, basically the big ones, and then the Schedule A2 development, which is likely to have significant effects on the environment by virtue of its factors such as its nature, size, or location, and this often applies to marine energy developments. Under amendments to the EIA regs in 2017, it is now possible to request a joint screening and scoping opinion to determine what information should be included in an environmental statement to support an application. And NRW have actually produced detailed guidance on EIA scoping for marine developments, and I've provided a link on the slide there. We're actually currently in the process of reviewing this guidance to make it more accessible on our website. So we're going to be launching that any day now. Actually, I think it's in the next week or so. So as soon as that's available, I'll also send around those links. So now a little bit about the HABs regs. So under the Conservation of Habitats and Species Regulations 2017, a habitats regulations assessment is required for all projects that have the potential to impact a European designated site, either directly or indirectly. European sites include special areas of conservation for the protection of habitats and species, and special protection areas for the protection of wild birds. As you can see by the map, the majority of Welsh waters are actually designated, 69% of inshore waters, in fact. And there's specific conservation objectives written for each of these sites and the habitats and species that they are protecting. And proposed activity must be considered alongside these objectives when completing a HRA. So the ultimate aim is to achieve favourable conservation status based on the features for which the site has been designated. Following completion of a HRA by the competent authority, and in marine licensing, the case of marine licensing, that is NRW, a project cannot be consented if adverse effect on integrity of European site cannot be ruled out after mitigation measures have been applied. The only way to consent a project with a conclusion of adverse effect is through the derogation process, which includes a test of alternatives, and imperative reasons of overriding public interest, and ultimately compensation for the impacts that are going to be caused. I can't really go into any detail, further detail on this piece of legislation now, because I simply don't have time. This would be multiple presentations to get through the HABs regs. So this is just sort of a starter, really. But for questions, really, as NRW as statutory nature conservation body for Wales can provide advice to applicants on this key piece of legislation. So please don't hesitate to get in touch if you have any questions relating to a project. So now my final slide, it's just a bit of a list of guidance that we have available on our website. So we've recently produced marine renewable specific pages on our website, which includes guidance, advice, and evidence and data linked to anything to do with a marine license application or any consent application to that effect. We've also got detailed information to help you guide you through the marine licensing process in terms of what should be included in your application, what additional assessments may be required, and that kind of thing. I've also provided a link there to the environmental assessment pages of NRW's website, which includes habitats regulations assessment, and also the designated sites pages. So you can search for specific designated sites that you may be interested about or need to include in an application, for example. We also have a discretionary advice service. So if you have any more detailed questions about projects and would like detailed input onto a specific project and some questions that arise, then please don't hesitate to get in touch. And then finally, for any specific matters relating to marine licensing, please contact the marine licensing inbox. So that's it for me. Thanks for listening. I can address any questions at the end of in the Q&A, but also if you have any specific questions, please don't hesitate to contact me via my email.
James, thank you very much. That was really an efficient run through of a complex area, as you indicated at the start. But you've covered a lot there, and you've given us also lots of really valuable links in terms of further work. There are questions coming in on Q&A for you, and I'm sure there'll be others. So just to encourage participants to put in your questions or comments in on the Q&A, and we'll pick those up. Other than the ones that can be sort of answered sort of directly and quickly, we'll pick up the discussion points at the end of the session. So James, thank you very much for that. Let's now move on to Jennifer and introduce Jennifer Fox, the Offshore Renewables Joint Industry Programme. So Jennifer, you're on.
Thanks, Peter. Can I just check that you can hear me and see my screen okay?
Yeah, we're good.
Great stuff. Okay, thanks a lot for that. And yeah, thanks to Jess and the MEW team for inviting me to speak today. So I'm going to talk a little bit about the Offshore Renewables Joint Industry Programme for Ocean Energy, or ORJIP Ocean Energy. As Peter said, my name is Jennifer Fox, and I'm a senior consultant working with a company called Aquaterra, based in Orkney in Scotland. And I'm also the program manager for ORJIP Ocean Energy. So I'm going to talk a little bit about that today, and I'm also going to talk about another program that we work really closely with called OES Environmental, and specifically on the work that they do around the Tethys website, which is a great resource for a lot of information on the environmental aspects of wave and tidal energy, and specifically on the State of the Science report that was produced by the OES Environmental team and came out earlier this year. So just to start by introducing ORJIP Ocean Energy. So ORJIP is a UK-based programme that has the overall aim of reducing the environmental consenting risks for wave and tidal energy. So I'll thank James for providing, setting the scene on the environmental consenting regime for wave and tidal energy, specifically in Wales. And hopefully I can talk a little bit more on how we as ORJIP work to facilitate a strategic and coordinated and prioritised approach to the monitoring and research that goes on around the environmental aspects of wave and tidal energy. The specific reason for that, and the reason that a programme like ORJIP Ocean Energy came to be, was in acknowledging the fact that this is a relatively new industry, and that there are knowledge gaps and related to those knowledge gaps, related environmental consenting risks for these projects, as we don't know everything yet about how the marine environment interacts with these devices that we put into the water. And so in order to reduce those risks and to reduce the knowledge gaps, we need to do a really high standard of monitoring and research around the devices and around how the environmental animals interact with those devices. And for the the best progression of the industry from a commercial aspect, we want to make sure that we are prioritizing and coordinating ourselves with that monitoring and research that goes on, so that the industry can progress in a way that is sustainable and that is acknowledging the sensitivities of the marine environment in which they are working. And so for us as ORJIP Ocean Energy, what we're really looking to do is to engage with all of the different types of stakeholders that work in the sector, from the industry themselves to the regulators that James was talking about, and the statutory nature conservation bodies, as well as the researchers within academia who are carrying out a lot of this monitoring and research that we're talking about, to really work with all of those different types of stakeholders and see, can we come to a consensus on where the priorities are for monitoring and research around devices, and ultimately to further our knowledge and our understanding of the interactions of the marine environment with the devices, to be able to consent the projects and move towards the commercialization of the sector in a sustainable way. So there are three main ways in which we, as the ORJIP Ocean Energy Programme, carry out that remit. The first one, as I've already talked about a little bit, is this discussion and consultation with the varied groups of stakeholders in order to be able to provide a forum for discussion and coming to some kind of consensus, or at least agreement on the key priorities for research, or the key uncertainties where research can be done to move us towards a place of better understanding of some key environmental issues within the sector. The second way that we do that is by making sure that the information and the knowledge and the increasing evidence base that is being created through this monitoring and research is being shared as widely as possible, both in the UK, and Jess talked a little bit about the work that was done in Scotland and now is being done more and more so in Wales. But there's a lot of work happening all over the world in relation to the wave and tidal industry. And so one of the key parts that ORJIP Ocean Energy plays within that is making sure that information is made available to interested parties in a way that is accessible. And then the third key method that I've highlighted here is through the written outputs of ORJIP Ocean Energy. And I've just listed three of the key ones here that I'm going to talk about in a little bit more detail. The Forward Look document, which was last updated in 2017, and two documents which are about to be published by ORJIP very soon on critical evidence needs and on sharing environmental monitoring data. So just to talk a little bit about the Forward Look document, I hope that some of you are already aware of this document, but it was first produced by ORJIP Ocean Energy back in 2015 and then updated in 2017. And this was done based on a lot of consultation and liaison work with different stakeholders within the UK, looking at where the key knowledge gaps or evidence gaps are in relation to the environmental aspects of the wave and tidal sector, and providing a list of those key knowledge gaps in a prioritized way. And in addition to that, providing a prioritized list of the ways in which those key evidence gaps could be addressed in the format of almost like mini research proposals that set out how these evidence gaps could be addressed and how these research proposals could be put in place in terms of the purpose, the required timing, and the scope of those projects in order to meet the overall aim of ORJIP, which is reducing that uncertainty and reducing the consenting risk for the wave and tidal energy sector. The second document that I wanted to highlight is one that is going to be published very soon by ORJIP Ocean Energy. And again, this has been consolidated or compiled through a lot of consultation and discussion with key stakeholders within the wave and tidal sector in the UK and internationally as well. And this document is essentially a condensed and updated version of that list of prioritized knowledge gaps for the environmental consenting of the wave and tidal energy sector. So I've pulled out a couple of the key examples. I just wanted to get specific on some of the examples that we're talking about here. This isn't everything that's within this report, but I did just want to pull out some of these examples. The first one here is on the methods and instruments to measure mobile species occupancy and behavior in high energy environments. So as Jess alluded to a little bit earlier, when we're working in these high energy environments like tidal sites or wave energy sites, it's a tricky area to work in, as I'm sure many of you are familiar with. You know, the fundamental aspect of working in a high energy environment makes it difficult to deploy instruments to measure the interactions or the behavior of animals in those areas. And so having those kind of key methodologies that are tried and tested and developed, as well as the instruments themselves to monitor the mobile species behavior and occupancy in those kind of environments is really important. The second one that I've got here is the occupancy patterns and fine scale distribution and behavior of the mobile species in high energy environments. So this is referring to our baseline understanding of how these kinds of animals, and I am talking about marine mammals such as whales and dolphins and seals, and also the birds as well as fish and other animals as well. I shouldn't leave those out, but having that kind of baseline understanding of how these animals use these types of high energy environments, you know, what are their behaviors within these types of environments, and what's the distribution and the scale of use that these environments are getting with these types of animals. The third one that I've got here is the near field interactions between mobile species and tidal stream turbines. And I should have said, I think Carol and Aly are both going to go into these aspects in a lot more detail, but I just wanted to pull out some of the examples that we're highlighting as part of the critical evidence needs coming from ORJIP. So yeah, the third one here, the near field interactions, this is a really important one and quite an obvious one. When we do deploy these types of tidal turbines into the marine environment, how are the animals that might be present in that area interacting with those tidal turbines, and is there a risk that there could be collision risk is a major aspect of the work that we do in trying to reduce our uncertainty around how animals interact with the devices themselves, and whether there is a risk of injury or death from the animals if a collision was to occur. There is definitely a level of uncertainty still, although we are building an evidence base, and a lot of really great work is being done by people like Carol and Aly at the moment to learn more about those interactions, but there's certainly more work to do in that area. The fourth item that I've got here is the far field responses of mobile species to wave and tidal stream devices and arrays. So this is referring to separate to that really up close interaction between the technologies and the animals. But when we've got, say, a larger array and we're looking to the further away responses of the animals, is there being a change in behaviors, or is the presence of the devices having an effect on the behavior or the presence of the animals in that area? And the final one that I've got here is the tools for assessing and managing risk to mobile species populations for large scale wave and tidal stream development. So as I mentioned, we have done a lot of work in this area. We are definitely building an evidence base and learning a lot about the interactions between animals and wave and tidal devices. But because the sector is in a relatively early stage still, most of the deployments have been either single device or small scale arrays. And so there's definitely still a question mark around when we scale up to large arrays, commercial scale arrays, will there be broader population level effects? And do we have the right kind of tools in place to be able to understand and manage the risks around those potential population level effects? And so that's something that, while we're not there yet, we definitely want to prioritize our abilities to manage those risks when we do come to a place of being able to scale up to these larger commercial scale arrays. So moving a little bit away from the specifics of ORJIP Ocean Energy and the work that we do in the UK, I also wanted to talk a little bit about a program called OES Environmental, which I'm sure, again, many of you are familiar with. This is a program that's run out of the Pacific Northwest National Laboratory in the US, but is very much a global program of knowledge sharing for the wave and tidal industry, specific to the environmental aspects of that industry. There's a number of countries, as you can see, I've listed here, that are member countries of the program. So those are countries that have signed up to say that they're very interested in the evidence base that is being built around our knowledge of the environmental aspects of the wave and tidal industry. And some key activities specific to what OES Environmental do that I wanted to highlight to you today. The first one is the TETHIS website. I hope many of you are quite familiar with that, but I wanted to highlight some of the key aspects of that resource because it's a fantastic resource if you are interested in learning more about the environmental aspects of the wave and tidal industry. In a very similar vein to what ORJIP Ocean Energy does in the UK, consultation and discussion with key stakeholders is a really important part of what OES Environmental does. And then finally, as I mentioned already, the State of the Science report, which was just published earlier this year, is a really important resource for understanding the environmental impacts of wave and tidal energy as well. So to talk a little bit about TETHIS to begin with, a couple of key aspects that I wanted to introduce specifically on this. Firstly is the knowledge base. So this is a repository of, I think, as you can see here, over 3,000 publications, journal articles, conference papers, presentations, lots and lots of different things here that have been produced on the topic of environmental impacts of wave and tidal energy, and it's fully searchable. So if there's particular aspects or particular projects or particular geographic regions that you're interested in, this is a really great way to find those reports and publications. There's also the metadata project pages of the TETHIS website, which is pages specific to where there are key projects that are ongoing or have happened in the past, specific to developers and areas. And each of these pages gives really great information on the current status of those projects, as well as all of the environmental monitoring or reports that have been produced in relation to those projects, as well as the technical aspects and some contact information if you're looking to find out more, and lots of links and things as well. So a really great resource if you're looking to get more information specifically on key projects. The next one, and this is a really important one as well, is, as I mentioned, a really important part of what OES Environmental and ORJIP both do is engaging with stakeholders and sharing information. And so there's a whole back catalogue here of the webinars and the workshops that have been carried out by the OES Environmental Programme. As you can imagine, in the last 6 or 8 months, all of this has been online rather than in-person workshops. And so the benefit of that is that it all gets recorded and uploaded here. And there's often all of the presentations are available and links to the key speakers and all of that. So if you haven't managed to attend those events, they're all available through the TETHIS website, and it's a really great repository of information there as well. And the final thing I wanted to mention specifically on TETHIS was that over the years, there's been a few different tools developed, specifically in relation to the environmental impact assessment around wave and tidal energy projects. And so there's a whole section on tools that is searchable, and this is just one that I wanted to highlight, which allows you to, if you're working on a particular project, you can search based on these categories for projects that are of a similar nature to the project that you're working on, and kind of narrow down the search and ultimately bring yourself to a page of results that shows you where there are projects of a similar nature that have been carried out in the past, and what environmental information or baseline studies have been done on those projects, so that you can have something to refer to when you are carrying out your own environmental impact assessment, or indeed just wanting to know what kind of baseline studies or what kind of information might have been collected on those previous projects. Okay, so to finish up, I just wanted to talk a little bit about the State of the Science report. So this is a summary report of the most current and pertinent published information on the interactions of marine energy devices with the animals and habitats in the marine environment. So I hope that a lot of you are quite familiar with this, but just to say that it's a really great example and the most comprehensive example of a summary of where we are at with our understanding and our evidence base on these key topics. So there are individual chapters dedicated to the key topics around the environmental aspects of wave and tide, collision risk, as I've mentioned, underwater noise, electromagnetic fields, changes in habitats, changes in oceanographic systems, encounters with mooring systems and cables, and finally socioeconomic impacts. So if you're looking to get an understanding on where we're at currently, and it is remarkable to note the quite extensive evidence base that has been built up over the last number of years in regards to these categories in relation to monitoring and research that has been done around deployed devices, although it does definitely highlight that there are still knowledge gaps and definitely still areas where work is needed. There are also additional chapters which kind of correspond well with what I've talked about in relation to ORJIP on the methodologies and technologies used in monitoring the devices, which is a really important aspect of what we're doing, as well as marine spatial planning, adaptive management, and finally risk retirement and data transferability. So I think I'll stop there. I've gone a little bit over my time, so apologies for that. But just to run through those strategic programs, and there's some links here to some of the things that I've mentioned. So I'll leave it there, and thank you very much. Happy to take any questions on any of that.
Jennifer, thank you very much. That was a good run through of the evidence base that is being built, allowing for the fact that there is still work to be done. And I'm sure that's going to be part of the discussion session at the end. So there are some questions on Q&A that have come in while you've been doing that. So you might want to just check those out and we'll come back to them at the end. Jennifer, thank you. We're now going to move on to Aly McCluskie from RSPB. Aly, are you okay to join?
Yes, thanks.
Good.
And can you see my screen there?
Yeah, that's good. Thank you, Aly.
Thank you. My name's Aly McCluskie. I'm a scientist with the RSPB with a focus on the interactions between developments and birds, and a particular focus over the last 10 years has been seabirds and all forms of marine energy. Today I'm largely talking about tidal energy, but much of the lessons of what I'm talking about can be applied to wave energy. I'm talking about tidal stream energy in particular. As I say, I work for the RSPB. I have the RSPB are very supportive of renewable energy. A large part of what my work involves around working with a variety of stakeholders, developments, statutory agencies to try and find a way forward for what, as we talked about already, the dual emergencies of climate and nature and how they interact and how we can resolve them together. So in this talk today, I'm going to talk just very generally, I run through the effects, the possible effects arising from tidal energy on birds, the species potentially affected, the potential vulnerabilities of those species, and I'll give some examples of how they can be somewhat nuanced, these potential vulnerabilities. I will then look at some of the modelling techniques to look at the impacts and some of the monitoring that can be used to monitor the impacts. You'll have noticed I said when I was talking about effects and species, I was talking about potentially affected. There's a lot of uncertainty in this, and I'll highlight that before I come to my conclusions. So the potential effects, they can be direct or indirect. The direct effects are collision, entrapment, disturbance, habitat exclusion, displacement, and pollution. Indirect effects can be increased turbidity, increased predation, and changes in prey availability. Clearly, some of these effects can be positive as well as negative. The changes in prey availability may be a good thing, although, as I'll talk later, it may actually increase collision risk by attracting animals around foraging hotspots. And these effects as well, collision, these effects, all of them can be lethal or sublethal. Collision we tend to think of as lethal, but with tidal energy, the collisions may not be lethal. There might be sublethal effects. Along with these other effects like disturbance, habitat exclusion, sublethal effects can have impacts on things like a bird's ability to catch prey, to provision chicks. These can have impacts on the number of eggs that are laid, the number of chicks that fledge, the number of chicks that survive through the winter, the adult survival itself. So there's a lot of subtle effects that are very difficult to get a handle on. The sort of species potentially affected, and I'm just working from the top here. These were all identified by a review carried out by Bob Furness a number of years ago. The review focused on Scottish species, but the lessons are equally applicable in Welsh waters. The species at greatest risk, and this is the top row, were black guillemot, razorbill, cormorant, shag, and the common guillemot. The species at medium risk were identified as great northern diver, red-throated diver. Both of these species that are here are in their winter plumage. The puffin and the black-throated diver. The vulnerabilities of these species arise in different ways. It can be their physiology, so whether they hunt visually or orally, and how that will affect their interaction with a device. The geography, and this is something that's been talked about, James talked about it already, in terms of the importance of a site. Is it a designated area? Is it close to a breeding area? Is it a wintering area? You saw with red-throated diver and great northern diver, it's more wintering species. Is it a foraging area? And for some of the auk species, the guillemots, razorbill and puffin, is it an area where they raft and molt and rest in? There's a demography of the species, whether or not the species is vulnerable, its conservation status, whether the population's in decline or increasing. And finally, there's the ecology, and a key part of the ecology is the foraging behaviour. Now, I'll just talk a little about some species and how ecological studies has helped to inform our understanding of their vulnerability. If we look at two of the species that are identified as high risk, the guillemot and razorbill, both are auks, and both superficially seem fairly similar. However, if you have a closer look at their foraging behaviour and flight behaviour, you see that there's differences, and these differences will affect how they interact with any device. So guillemots and razorbills both fly close to the surface, so there's potential for interacting with any above surface structure. Guillemots spend more time diving, and razorbills spend more time in flight. So this would put guillemot more at risk of interaction under the surface. Razorbill make few long and deep dives, whereas razorbill tend to make lots of short, shallow dives. So this will, depending on where the device is in the water column, will influence how the species are impacted on. Guillemots have a faster dive speed, razorbill have a slower dive speed. Again, this can influence how they interact with the device. And guillemot tend to go into very narrow kind of areas for foraging locations, whereas razorbill have a broader spread. So all these sort of ecological bits of information can help us understand the interactions. Similarly, cormorant and shag are superficially very similar, but they are quite different in some ways. Cormorants were assumed some time ago to be pursuit divers until there was dissection of the eyes, and it turns out they've got very poor sight and actually catch the prey at close quarters just after detecting it. This poor sight could potentially make them more at risk of negative interactions with devices. Shags, it turns out, have mounting cameras on shags has revealed that they have different foraging strategies for different benthic substrates. Sometimes they'll be pursuit divers, sometimes they'll be close, they'll rely on close field detection. So these show that there will be different circumstances with the shags depending on where the devices are, on how they will be behaving there and how they'll interact with it. And it also shows how novel investigative techniques can really be informative to help us understand the ecology. But all of this, the examples of inferences of the impact, it's all talking about the potential impact of ecology, and the actual evidence of interactions, particularly in the near field with devices, is scant. So in this absence of evidence impacts, in order to carry out the sort of assessments that James was talking about, the impacts must be modelled. And a key impact for birds with tidal energy is going to be collision. And these two models that are used, the encounter rate model and the collision risk model, and they both take what we call input parameters, which will be measures of the dimensions of the device, the speed that they rotate at, that sort of thing, and combine it with biological parameters such as dive depth and dive speed and size of the birds, and they will model the risk of collision from the devices. Both of them need to account for avoidance of the devices, and this isn't actually modelled itself, it's included as a correction factor known as avoidance rate. And it turns out that that avoidance rate also includes all sorts of model error and variability, and it's an aspect that in wind energy, the inclusion of avoidance rate has attracted a great amount of debate, and it's even more complicated in the subsurface environment because of the aggregation of prey species leading to attraction. So the results of any monitoring must feed back to the modelling. So it's a loop to improve the model parameterization and also to validate the model. Both of these collision risk models there's a complete absence of actual validation and testing how accurate they are. The monitoring methods, as we've previously said, there is scant evidence, and all our understanding to an extent is inferences from ecology. So we need this good monitoring to feed back into the modelling, to feed back into the assessment, to understand the nature of impacts and how serious they are. Monitoring can be via tracking the individuals potentially impacted. This is usually using something like a GPS tag, which will give information on the bird's behaviour and locality. It can include what's known as a time depth recorder that will give you information on the depth that the birds are diving to and how long they spend underwater. All of this is useful information, but there's a lot of issues around how you attach the tag to the bird, and you also need to get the data from the bird itself once the tag's recorded it, so you can either recapture it or have some sort of remote download. Other important monitoring is monitoring the potentially impacted population. So this needs detailed counts at the colony in question, looking not just at the numbers of birds, but also their productivity, to look at some of the sub-lethal impacts I talked about already. There can be direct observation carried out of the behaviour above the sea surface. This can be done from the shore if the devices are close to the shore. They can be from planes or boats, or even via drones, or there can be surface-mounted cameras on the devices themselves. There can also be direct observation below the surface. Hydroacoustic methods such as sonar, although there are real problems with species identification with sonar with birds, much less so with marine mammals. And there's also underwater cameras. However, the underwater cameras need good viewing conditions. There has been some success in a site in Shetland at Blue Mill Sound, where Nova Innovations have got cameras, but they have very unique conditions there, and often underwater cameras, because of the light conditions and the turbidity, can't record either, and there can also be biofouling. The key of what we're looking for in monitoring is understanding the three-dimensional behaviour of the birds in the vicinity of the devices. And once we understand that, also understanding that how that potentially and actually puts the animal at risk of collision. So ideally we would, with this monitoring, would follow the individual bird through the interaction with the device, right the way through to any population scale impact. As I've highlighted, there's considerable uncertainty in this, and until we have further research and monitoring to increase our understanding, we must use the precautionary principle. The precautionary principle is legally entrenched. It comes from the Hippocratic Oath, primum non nocere, first do no harm, and is best summed up as where uncertainty still exists, we must give the environment the benefit of the doubt. And as I say, that's a legal requirement in an assessment. So finally, there is considerable uncertainty remaining about the impact of tidal energy devices on birds. In particular, understanding the three-dimensional behaviour of birds in the vicinity of turbines is required. The technology to fully capture this behaviour, unfortunately, is still not available, though there are potential routes to follow. The population consequences of these individual interactions with devices must be understood. And that is the kind of question, does it matter? And finally, and this has been already talked about, what will happen when we scale up to bigger arrays of devices in large scale? And we need to understand, first of all, in the small scale before we can even understand on the large scale. And I'd just like to say thank you for inviting me and for listening to me. And I'll look forward to the discussions afterwards. Thank you.
Ali, thank you very much indeed. You've set the issues out really clearly there, and we will come back to them. We've got about 20 minutes or so before we need to go into the discussion session. So we've got two speakers left to share their thoughts with us. And so let me go first to Carol Sparling, the Sea Mammal Research Unit at the University of St Andrews. So welcome, Carol.
Hi there, thank you. Can I just check that you can see my presentation and you can all hear me?
Yep, good.
Great, okay. So hi there, thanks to Jess and to Marine Energy Wales for the invitation to join the panel and to talk to you all today. I've been working to support the sustainable development of renewable energy since 2007, I think. And I've been involved in research on the effects of tidal energy developments on marine mammals since the installation of CGen, the world's first commercial scale tidal turbine in Strangford Lough in Northern Ireland. And since then, I think I've worked on most of the UK's tidal energy projects in one form or another. And And I've also worked across all stages of project life cycle, including, surprisingly for the stage of the industry, decommissioning of CGen. So today I'm just going to give a brief overview of what the main concerns are in relation to the potential impacts of specifically tidal stream energy developments on marine mammals. And Jen's already gone over the same things I'll talk about, and a lot of the parallels with the situation for birds that Aly spoke about. I'm going to give a whistle-stop tour through some of the findings from the monitoring and research that's been carried out globally to date. And then I'll go on to highlight what I think are the critical knowledge gaps, and my own take on where I think the priorities really lie in terms of where we go next. So why are we concerned about the potential impacts on marine mammals? Well, areas of high tidal energy potential often do overlap with areas that are important for marine mammals. And this has led to concerns about the potential for adverse effects, and particularly in areas where marine mammal populations have not been doing so well. So a good example of that is in Orkney in Scotland, where the harbour seal population has drastically declined over the past decade, which is also an area that's been earmarked for a lot of tidal energy development. Also in other parts of the world where there are small isolated populations, such as the west coast of the US and Canada, where concern around potential effects on the endangered southern resident killer whale population has led to delays and cancelling of projects. In some cases, populations so sensitive that impacts on even a single individual would be considered a population level impact. And I guess the closest parallel you have in Wales is the small bottlenose dolphin population associated with the Cardigan Bay Special Area of Conservation. Many places around the world, these concerns have led to delays in consenting, and as we've heard, the requirement for the development and implementation of expensive and somewhat challenging monitoring programs. So what are the specific concerns? And these are quite similar to the ones that Aly highlighted for birds. And firstly, probably collision is the single biggest concern, the potential for animals to be directly struck by moving parts of devices. But also disturbance, and related to that disturbance, displacement and exclusion from important habitats, and the potential for effects disrupting animal movements, so transits and migrations, and also indirect impacts so any effects on prey will undoubtedly have knock-on effects on the predators, and that could be positive or negative in terms of whatever direction the effect on the prey are. And so how far have we come in terms of our learning over the last decade or so since the installation of CGen back in 2008? And we've actually come quite far. I think collectively we've achieved a significant amount of monitoring around single devices, test centres and small arrays. I'm going to run through, by no means completely exhaustive, but hopefully pick out some significant examples of that. And while doing so, I'll also pull out and highlight the range of the different monitoring techniques and technologies that have been employed across these projects. So to start off with, in terms of technologies for monitoring, we've seen a lot of use of animal-borne telemetry with seals. So that's the attachment of devices that can record and transmit information about seal movements and how they're behaving in tidal environments and how they're behaving in relation to devices. So we can compare behavior when turbines are operating compared to where they're not, for example. That's been used in CGen, a 3-year monitoring project using telemetry in CGen. We've also seen seal telemetry deployed in the Pentland Firth to look at responses to the Maygen array. And this plot here just shows an example of where we've seen some evidence of displacement and avoidance around operating turbines up there. Passive acoustic monitoring is also a very widely used technique, and that's used to pick up the sounds that echolocating whales, dolphins and porpoises make underwater. And the image is on this slide here, shows the placement of the array of hydrophones on the foundation of the Atlantis turbine in Maygen. Passive acoustic monitoring has been deployed at a whole range of sites in the UK and globally. For example, at the Force Energy tidal site in Nova Scotia, as well as information about avoidance of devices from harbour purposes, we've actually very recently managed to get some really exciting close-range behavioural data, the kind of holy grail of monitoring around tidal turbines. And this is an example of a track of a porpoise swimming past the Magen Atlantis turbine while it was operating. Which is very exciting stuff. Active acoustics is also a very popular method for monitoring in close range around turbines. We've seen that in use at CGen, although primarily more as a mitigation tool than a monitoring tool per se. Sonar hasn't been as successful as passive acoustic monitoring has been to date, but we're hoping to change that with an upcoming deployment of a dual sonar, a multi-beam sonar platform at Magen early in the new year. And the image that I've just put up here is actually, that's an image that I took yesterday from a screenshot of a platform that's currently been deployed and under test in the Tay estuary near us in St Andrews prior to deployment at Magen in the new year. But sonar has been trialled at a wide number of sites globally as well, with not quite as much data coming from those projects as we've seen with some of the other monitoring techniques. Underwater video has been used again at a number of sites. It's been used at various test deployments at EMEC. It's been used at Magen, and as Ali said, very successfully at Nova, where there's some really good video footage and some insights into underwater interactions at the Nova site in Shetland. And this Nature Scott report provides a comprehensive review of video monitoring and the information that's been collected to date and made available for that review. And it's quite a useful report for anyone considering the use of underwater video. So hopefully that very, very quick tour of the technologies and projects that have been monitored gives you an overview of the range of different technologies, and hopefully it's shown that there isn't really a single technology that will work at all sites for all species for all questions. And most projects have relied on a suite of complementary measures to collect data on key species and key questions of interest. So to bring together some of the key outcomes from those studies that I've very, very quickly rushed through, just to summarise to date what are the most important findings. We have seen evidence of reduction in abundance around turbines in a number of species. We've seen that in harbour seals at different sites. We've seen that at CGen, where tagged harbour seals demonstrated a reduction in their activity around the turbine. Similarly, not an actual turbine, but playbacks of turbine noise. We saw a reduction in activity around the source of those playback trials. And then the more recent telemetry data at Magen, we've seen a reduction around the operating array of turbines to about 30% reduction compared to when the turbines weren't operating. We've seen similar reductions in kind of a small scale around the Magen array from the passive acoustic monitoring that I talked about earlier. There's also been studies at the Force Centre using CPODs looking at changes in activity in relation to deployment and operation of turbines there, and they've similarly shown a reduction in porpoises around operating and during the installation of turbines. We are starting to get more information now on the very close range 3D interactions, so that track I showed you from the porpoise at Magen is probably the first example of that. And what we found there is that there were no transits through the rotor swept area while the turbine was operating, and that was after a year of monitoring, so 12 months of 24/7. And we actually also picked up evidence of close range avoidance, so animals seeming to spend more time around the turbine base and actively avoiding the areas around the rotors. And a number of those papers are actually are not publicly available yet, but we've summarised the outcomes in a number of presentations and webinars that will be available through the ORJIP links and the OES links that Jen shared. But we're hoping that those full papers will be out relatively soon. And also in terms of the video monitoring at Nova and Shetland, some promising information there in terms of harbour seal detections being all below cut-in speed of the turbine. So we look with interest for the rest of that data set to be analysed to confirm that pattern more completely. So the remaining knowledge gaps, where do we still need to spend our efforts on information, getting information? I think particularly relevant for whales, we are lacking data for some species, and for the species that are priority species in whales, we don't have a lot of monitoring data to describe reactions and responses for grey seals, bottlenose dolphins, other species of dolphins, Rousseau's dolphins, common dolphins, etc. So there's an obvious need there. We still do need more information on 3D fine scale behaviour. We have it now for one species in one site, and we still don't know whether collisions are likely to occur or will occur at all. And monitoring very rare events, although that one rare event could have quite significant consequences. Monitoring rare events is very difficult, so it's hard to prove a negative, and it's hard to rule out the possibility of collisions, particularly for smaller, more sensitive populations. And as has been said before by the two previous speakers, displacement consequences at the population level, and how those will scale up as we move up to commercial arrays. I won't labour that point any further. So the priorities for where we need to go next, I think, is we really need to fill those data gaps for key species. I think we can't necessarily draw parallels between species that are maybe operating in quite different habitats and different behaviours. And I think we also need to make sure that we're having the right discussions around how the data that are coming out of these studies are implemented into future assessment frameworks. That's potentially quite a kind of complex area that I'd be very happy to discuss with anyone in more detail, but probably more than I can go into right now. And I think, again, as my colleagues have also said, that understanding displacement and the consequences for that, and developing approaches for how that's assessed as we scale up, I think is going to be a key area of progress, or needs to be a key area of progress in the future. And then finally, I think that the range of studies I showed previously have kind of taught us that we can generate quite a huge volume of information and data, but without the tools and the technology to allow us to efficiently process that information to make the inferences we need to, we're kind of in a bit of trouble. And the data to volumes that we're collecting, and you might have heard the term data mortgages used, we can be quite limited in how much we can actually process those data. So we need to develop the tools that allow us to improve how we process and make that less labour intensive and more cost effective. And that's not just for underwater video data, but that's also for sonar data. I think the passive acoustic monitoring data were a little bit ahead on that in terms of proven methods for species ID and classification, but the other more image-based techniques we need to do a bit more work on. And I think that's all I have to say just now. But yeah, looking forward to the discussion, and happy for anyone to get in touch and to talk about any of the things I presented in more detail. Thank you.
Great, thank you, Carol. That's really good coverage of the impact on sea mammals. So let's go to our final contributor on the panel, and that's Paul Ellsmore from the Marine Energy and Engineering Centre of Excellence. And then after Paul, we'll go into the Q&A session. So make sure you put your questions up on the Q&A section, and add your questions in now so we can cover them. So Paul, welcome. Final panelist. Thank you very much, least but not last.
Okay, thanks, Peter.
I mean.
Yeah. Okay, let me see. Can you now see that?
Yes.
Okay, excellent. I'll rattle through this a bit quicker than I expected because we haven't got a lot of time, I know. So, hang on. I can't seem to make my slides move.
You're not in full. If you go into full, you're not in full presentation.
Oh, well, I am on my screen.
Okay. We can see the slide, but we've got your other slides down the side as well. So
did it move slides just then?
Yes, it did. Yeah.
Okay.
We are now on the catapult network slide.
Yeah. Okay. So if you're okay to continue like that, because I can't.
Yeah, fine.
Yeah, fine. Okay. Yes, I'll rattle through this. You don't really need to know too much about the catapult network, except that there's a lot of us and we're all over the country. My own particular catapult, the Offshore Renewable Energy catapult, has offices around the country as well, including our Marine Energy Engineering Centre of Excellence in Pembrokeshire. That's just the project. We do have a more meaningful presence outside of that project as well. Just to give a very brief bit of background, we cover, as a catapult, we cover all offshore renewables. Offshore wind clearly is more commercially advanced than wave and tidal. It's important to Wales as well because floating wind has just come right up the agenda. So there's an awful lot of work going on in that space, and they still have environmental monitoring issues that need to be addressed. I mention that because they've also got the money to address it, which isn't necessarily the case in the wave and tidal markets. Tidal stream energy, really, it's on the brink of commercial viability, just needs a little bit more revenue support, the same as wind had over the last 10 years. And wave energy is a bit further behind, but still a huge global market available when it becomes available. And just for those reasons, basically 80% of our work is done in offshore wind at the moment, and only about 20% in wave and tidal, but we think it's pretty important work we're doing there as well. So just very briefly, I've been talking about this on MEW in meetings and working groups and webinars for 2 or 3 years now. We're still kind of getting it all together, but it's basically, this is a 5-year project around £11 million, but that relies on city deal money, which I haven't quite got yet. And the whole point is for us to carry out, on behalf of Welsh companies, innovation projects that they don't need to spend their own money on, that will help support them to bring new products and services to the market. We're very friendly in terms of intellectual property. It's a question that gets asked a lot. We don't want to own any intellectual property, but we do have to comply with state aid rules. But we do the best we can within that. And we're also going to play a bigger, increasing role in just generally sharing lessons learned, sharing knowledge, trying to promote the outputs of research projects as much as we can. And currently, well, again, I think you can read through that at your leisure afterwards. First thing we're going to do, hopefully this year, we've acquired a large buoy. It used to belong to Marine Power Systems. We're repurposing it, and we'll deploy that in META, in the Marine Energy Test Area. We've got 3 projects based around that. And this is the kind of thing that we will do with some of our money, is buy assets and deploy them so that we can do projects based around those assets. And we hope to have another platform, maybe 2, some kind of barge in the water early next year that we can do various tests from. So we use those assets to make it easier for our client companies to demonstrate their technologies. We're also building a portfolio of projects. We won't just be MEECE. We're already involved in the Milford Haven Energy Kingdom project and the Tiger project, which we have to tell everybody is the largest Interreg project ever funded by the EU. And it's got a big component in Ramsey Sound. But basically what we're looking for is innovators. We're looking for innovators that we can help take their idea to market. Difficult times for everybody with COVID, but the idea is that if you can explain your concept to us, we can pretty much take that on and develop it closer towards a commercial product or service with very little input from you. So, you know, if you've got your heads down now because of COVID, you can still be innovating, you can still drive your innovative ideas forward. We don't give grants, but like I said before, you don't have to pay us for the work we do either. So, innovation challenges, very, very quickly through this. As a catapult, we've been very successful with offshore wind. We've got a model that we follow through the Offshore Wind Innovation Hub, which is very much done in partnership with the Knowledge Transfer Network. I was going to navigate through their site, but I don't think I need to do that yet. But that's what it looks like. And I plan over the course of the next 3 to 5 years to use this particular site to promote our innovation challenges. And an innovation challenge, what does it look like? Well, from our point of view, it needs a very clear statement of the the problem that needs solving. It needs an owner, it needs a customer for the solution, if you like. So we need to find out if we're going to do an innovation challenge around environmental monitoring, we need somebody to step up and say, this is the problem I have. And then we need to know what the market for the solution is. This is an absolutely key point with offshore wind, because we're talking about companies developing solutions, spending their own money in a lot of cases to develop solutions. They need to know how much money are they going to make out of that solution, and who are they going to sell it to. So a lot of what we do with the innovation challenges is bringing the solution providers right in front of their potential customers and helping them demonstrate that their new product or new service actually does what the customer wants. I want to be clear that we can cope with, this isn't necessarily the case with offshore wind, but within the marine energy sector, we can cope with solutions at any stage of development. They could be a back of the envelope concept, or they could be actual off-the-shelf solutions in a different sector that have never been used in our sector. And we can help demonstrate that existing solution in a different environment, in a different context, and bear the cost of doing that. And also, solutions don't need to be complete. You might have an idea that's part of a solution, but maybe you need complementary assets, you need complementary companies to work with to turn that into a proper solution. And we can help find partners for you, and we can help to find further funding if the money that we've got available at the moment isn't enough to take that solution all the way to market. So just to give you an idea of how things would go, I've invented a monitoring diving birds innovation challenge. As previous, Aly in particular said, we need to know how tidal turbines affect diving birds. So this is key information for consenting bodies who could be a customer. It's key information for other stakeholders. RSPB could be a customer. The local community, when we're trying to get approval for these things, they need to know this kind of background. And it's also key information for the turbine designers themselves. They need to know, is there actually a problem? And if there is, can it be designed out at the design stage for that turbine device? And here's a mad idea that I haven't done any technical due diligence on, but imagine putting a pinger, imagine putting a ring on a diving bird's leg that actually emits a sonic signal underwater. Could that be tracked to get that 3D behavior underwater via an array of microphones maybe? And so the way we would look at this is we would look at the issues. We would try and work out what's the important factor about this potential solution. Is it small enough, light enough that it doesn't actually of itself change that bird's behavior? Can we power it? Is it going to survive? Is it going to be able to do its job long enough? It's going to need an array of microphones, but how do you get the data out of those microphones? Do we need cables? Do we have to go out and pick up hard disks every now and then? And what about noise pollution? And thinking about that in both directions. Can we actually hear the signal against the background noise? Or does the noise that the tag makes actually contribute to noise pollution? And what could MEECE do in this respect? Well, we would immediately do some desk studies, but we could fund the design of a prototype, the manufacture of a set of prototypes, and the cost of getting those prototypes out into the water, up to some reasonable limit. We'd also be interested in building and operating the array of microphones, and that could be something that we would operate as a test asset ourselves. So it wouldn't necessarily need to just go in the water for these tests. We might use it for other purposes. But most importantly, catapults build consortia of interested parties and bring people together to, to generate meaningful solutions to problems. So what next? Well, we're still working with the various stakeholders to refine the challenge, and we may end up with more than one challenge. This certainly won't be a one-off. We'll be doing innovation challenges over the next 3 to 5 years. We still want to work with KTN to fully understand their process. They have, outside of the Offshore Wind Innovation Hub, they have their own list of challenges for different market sectors. I think we'd like to see marine energy or wave and tidal separately on their list of sectors. We're talking to them about that. We still don't have a MEECE website. That's being procured at the moment. We're grant funded by WEFO, so we have to do everything through the right procurement process. And that website will become the major way of getting our ideas out to our community. I think we'll discuss this further with MEW, but I think we'll probably convene a workshop, or maybe more than one workshop, to develop this idea of an innovation challenge further, or maybe as part of the innovation challenge process. And at the moment, anything we do in the near future will be going through MEW and KTN as well as our website. But KTN, I'm hoping, will be our route to innovation challenges in the future. And there'll be more on a regular basis. So that's an absolute whistle-stop tour of those. And I was happy to share my slides. And if you want to have a further conversation with us, just drop us an email or drop MEW a note, and they'll get through to us in the absence of our own website. Okay, that's me, Peter.
Brilliant. Thank you, Paul, and thank you for allowing us to catch up a little bit of time at the end of the presentations as well, but not too rushed through. That was an important part of the session in terms of highlighting the innovation challenge that we need now to make sure that colleagues online are informed about and can respond to. Okay, so we now move into the discussion session with the panel. So if you can pop your cameras back on, the panelists can pop your videos back on so that we can see you, and we can then begin to sort of pick up some of the questions and answers and provide answers to those questions from the discussion that people have put online while we've been talking. I think if I just pick up, perhaps just pick up some of the specific ones, perhaps beginning with James, really. You'll see there are some specific ones related to your presentation, James, in terms of how NRW operate in respect of the application process, and in particular the point about the monitoring and collection of data on environmental impacts by developers, and how that information is used and built upon. I'm assuming you can see that question, which came in from an anonymous attendee, 1058. Have you got that, James?
Just to note, Peter, that the attendees can't view the questions in the Q&A that some others have submitted, so it's worth reading them out in full.
Okay, yeah, all right. So just James, just pointing you to this question, which is around marine licenses always come with conditions on the applicant, and understandably with conditions to monitor and collect data on the environmental impacts. This costs developers significant amounts of time and money. What does NRW do with this information they have requested, and are any conclusions reached using this information which may lead to the relaxation or perhaps more focused requirements of marine licensing conditions going forward? Is there any evidence of progression from both industry and regulation and regulator? I guess that point about progression is a sort of general point that comes up on a number of the points that have been raised. Yeah, are we building forward? Are we seeing progression in how we're dealing with the issues?
Okay, thanks, Peter. I can't see the question myself, so I just go on what you've just said.
Okay.
So essentially, in terms of conditions on marine licenses and monitoring that's required, we only ever ask for additional monitoring if it's really necessary. And with the marine renewable energy sector and offshore renewables in general, there's a lot of uncertainty. So we do need to ask for that information in order to be able to progress the projects. What we have in place at the moment is sort of an adaptive management style approach to consenting, where we allow developments to be consented in phases, and in order to be able to move to the next phase, you have to provide a certain amount of information. We are currently, we've already written some guidance on our website for adaptive management, and I can provide those links. But we're also providing, we're currently writing more detailed guidance on how we would like developers and applicants to propose these kind of projects and how they can progress through different phases. When more information is available, obviously our specialists will take that on board and use that information to be able to inform future advice. So it's kind of like a chicken and egg situation until you have devices in the water and you can be monitoring them to be able to get that information, then we're not going to know more to be able to sort of progress the sector, really. So yeah, I think that kind of covers what you're asking, but it's hard to say.
Okay, and just to sort of throw another one back at you, connected really, I think. Question for James. Great presentation. As part of the environment, hold on a second, I need to clear that off my screen. There we are. As part of an environmental statement, a developer must consider cumulative impact assessments. I always feel this is a weak area. What if any system is in place for NRW to assess cumulative impacts?
Okay, I can see that one actually. Thanks, Chris. Yeah, so cumulative impact assessment. Well, that a nice easy question. It's very complex. Let's put it that way. As I was speaking about marine renewable energy and project design envelopes, if the wider the project design envelope and the more uncertainty, obviously, the more difficult the cumulative impact assessment is going to be. I mean, in terms of our position, we don't have a specific position on how to undertake cumulative impact assessment, but what we can do is work with an applicant to try and identify what other projects need to be considered, what may be going in the water imminently, and that kind of thing. It's not just a problem in Wales. I mean, it's an issue across all UK regulators that we're all trying to grapple with. And NRW have obviously recognised this, and we're trying to work our own way of dealing with it, but also trying to bring together sort of knowledge from across other regulators and SNCBs in the UK to try and come up with some of the answers. So we're currently working with Marine Scotland on a project, a cumulative effects framework project, which is looking at cumulative impacts on ornithology and marine mammals, and that's a 2-year project which is starting early next year. So we're going to be we're on a steering group for that, and there's also a lot of work going on with the Crown Estate on their offshore wind round 4 evidence work at the moment as well. So all I can say is there's lots of work going on, and we're trying to get our heads around it, so we can advise our applicants better, really.
Yeah, as Phil has said in the chat, I can confirm that this is very complicated in terms of experience of cumulative impact assessment. Just before we leave you, James, there was one other I wanted to come back to. Yeah, does the NRW recognise the state of the art report, state of the nation, state of science report?
Yes, absolutely. Yeah. But the state of science report is a key sort of piece of information for us as well as advisors on environmental impact. I mean, they've done a huge amount of work across the sector, bringing together available information, and our specialists use that to help guide their advice, but also identify some of the key evidence gaps which we're trying to address at the moment. So we're currently working with colleagues in the Consenting Strategic Advisory Group with Marine Energy Wales and NGOs and also developers to try and address some of these key evidence gaps. And ORJIP Ocean Energy, Jen was discussing, are helping us with that as well. So it's the State of Science report is just one of a number of reports, but it's seen as a kind of the sort of global information gathering exercise. So yeah, we definitely use it, and it will inform our advice.
Okay, just going back to the other panelists, any other comments on, particularly on that state of the science report, which obviously is a significant piece of work, and Carol, you highlighted that. It does highlight the further work that needs to be done as well. But I think the important point about building on the evidence base and then identifying the gaps and then continuing to build on that cumulative data is really important. But it also needs to we also need to make sure that everybody is sort of coming along with it in the same at the same way. So have we got disagreements about what the state of science report actually says? Perhaps looking to Aly on that. Are there sort of concerns about the state of science report in the NGO sector?
I wouldn't say so. I mean, the report is very well written. It's very thorough. The key issue in terms of the RSPB is obviously birds, and the report does highlight the uncertainties for birds. And I think that it's an important point that we all need to take on board to understand that there is considerable uncertainty, and find the resolution to that. And so, because it highlights the uncertainty, I think it's an important step forward.
Yeah, no, good. Thanks, Aly. Carol, do you want to come back on that? Because I think it is such an important part of this picture in terms of how we're building the evidence base, identifying what still needs to be looked at. Although I guess we're still going to have to manage uncertainties, and that's come through in a lot of the questions as well. You know, the uncertainties are not necessarily going to go away.
Yeah, and I think that's where the critical importance of what James highlighted in terms of the approach to it's how regulators and advisors can cope with decision making and progress under uncertainty. So it's the development of those adaptive management frameworks. And so that, I think that means from my perspective, from a research perspective or a biological perspective, is being very clear about the questions that program needs to answer, and what those what's being monitored, what metrics are required, what would trigger the kind of release to the next phase, what would trigger concern, looking at it from the other direction. And that kind of ties into one of the points I made in my presentation about needing to understand how the data that are coming out of the monitoring programs, how those are interpreted in assessments or in that adaptive management framework. And that sounds like a fairly simple thing to do. And I think when we all started designing the monitoring studies, we all had reasonably kind of maybe idea in our heads about what those data would mean and what they would inform. But it's only now that the data are coming out, we're actually really kind of maybe realizing it's not quite as simple as we thought. I mean, Aly made the good point about the avoidance rate in collision risk modeling, for example. We maybe thought that what we're actually going to monitor is get this number, this magic avoidance rate that we can then plug back into an equation, which will give us the answer for, consenting the next project. But as Aly rightly said, that the avoidance rate is actually, it's a mixture of a whole bunch of uncertainties. We might be measuring, a reduction in local avoidance, or we might be measuring how a behavior changes. And those things don't necessarily always translate nicely into a quantitative value that we can plug into our collision risk models. So I think at the design stage of an adaptive management and monitoring program, that it needs to be really clear for all concerned, including the developers and the people that they're employing to do their monitoring and data analysis for them, that there's a framework and there's an understanding about what metrics are being measured and what those metrics maybe need to be to provide confidence that impacts are below a certain level. That's not an easy thing to do, I think, as experience is telling us now, but I think it needs more thought than we've previously given it, I think, at the design stage.
Jennifer, what about your thoughts? Obviously, you're at the centre of producing that work.
Well, not quite the centre. I won't take credit for the whole thing, but yeah, I think there's been some really good points made by the other speakers. And I just wanted to pick up, going back to the first question that James was talking about, the marine license conditions and the work that's done by developers and researchers on deployed devices. I think it's really important to note, I fully agree with what James was saying about the the work that NRW does in gathering information as a regulator and putting marine license conditions on developers. But as industry members and researchers and other types of stakeholders, I think it's really important for us also to be proactive and not to put all the burden on the regulators to learn from previous monitoring efforts and pieces of research that have gone on. And that's why as strategic programs like ORJIP and OES Environmental, we make so much effort in try to make information available and accessible so that when new projects come along, they don't have to reinvent the wheel every time. And I think, James, I hope you'd agree that the regulators are really supportive of this. You know, we absolutely don't want to be reinventing the wheel. And it's really important that as we're doing environmental impact assessments and as new developments are coming along, we are learning from the previous monitoring efforts that have been done and using the resources that are out there, like the State of the Science and like the Forward Look and the TETHIS website and all of these things, because there's a huge evidence base out there and we need to be pushing it forward with each new project and with each new effort.
Thanks, Jennifer. And there's some points. Last point came up from Blaise Bullimore. You know, this point about clearly we need environmentally benign kit in the water as fast as possible. Are the current research and regulatory approaches fit for purpose to deliver the speed required? I know I was on the UK Sustainable Development Commission back in 2007-8 when we produced the Turning the Tide report on renewable marine renewables, and so we've made some progress. It's been encouraging. Carol, I think, recognized the progress has been made, but whether this progress is fast enough and whether we can accelerate the current research and approach that we're taking so that we take on board the precautionary principles but make progress in delivering against the climate emergency agenda. I think that's a sort of key point, and whether we are building on the information that we're gathering year on year, which it seems to be that we are. But there was a question here which I think perhaps goes back to all of you, but particularly to James. Yeah, how can regulators incorporate research outputs, details from scientific papers, etc.? How can this be best? How can they best serve as contributors to the sector and the consenting projects separate to an environmental impact assessment? I guess, you know, how can all of those elements best contribute to building that evidence base that can be taken on board? That was from Gemma, if you can see that question. Are we able to take that on? Are we able to sort of engage effectively with those people who are undertaking that research output, those research processes and building in scientific papers? Is that possibly what Paul is offering as well in terms of the capacity to innovate in the monitoring and assessment as being critical to this process too? James, do you want to come back in on that? There's also a couple of other points you might want to just touch on as well, but do you want to just look at that point?
Sorry, James, you're on mute there.
Schoolboy,
and,
yeah, okay.
And a specific one for you, James. Projects over 350 megawatt, is the decision made by the Secretary of State for Wales, Planning Inspectorate Wales, or by the UK Secretary of State?
Oh, that's a quick one, that's easy. So over 350 megawatts is UK Secretary of State. It's a report from the Planning Inspectorate goes to the UK Secretary of State to make a decision.
Brilliant. There we go.
I'll just come back to Gemma's question. So in terms of technical scientific reports, our technical specialists, you know, our receptor-specific specialists, like our marine mammal advisors, our ornithologists, they all keep up to speed with what's going on in their sort of, you know, their science area. And that feeds into their advice all the time. We're also involved in collaborative work with particular universities. We also commission our own evidence projects as well to try and answer some of these evidence gaps. And there's work ongoing at the moment with Swansea University, I think, on a fish tracking feasibility study around Wales. So that's a particular project we're involved in. But there's all sorts of collaborative efforts that we're trying to get on. Well, we're trying to get off the ground and have been working on. So yeah, we try our best to keep up to speed. Thanks, Gemma.
And just a quick one from Fion, this one about blue carbon. How is the impact on blue carbon taken into account on marine licensing?
Oof, gosh, that one's hold on, let me just read it.
So blue carbon habitats in Wales currently store at least 10 years worth of lodged carbon emissions. This carbon stored over the millennia is sensitive to physical disturbance and is at risk of being released. How is blue carbon taken into account in the marine licensing process?
I couldn't speak. I'm not in the marine licensing team myself, so I couldn't speak for them. But I mean, blue carbon, as she suggests, is stored in particular habitats, and in a way, indirectly through the Habitats Directive and Habitats regulations, we are trying to protect those habitats in terms of salt marsh, for example, which is obviously a carbon store. And any impact to those habitats will obviously have to be considered by the marine licensing team. It's the same with special sites of scientific interest, for example, and other habitats that are on the such as seagrass. So yes, they are considered, and our advisors to the marine licensing team, and as statutory nature conservation body for Wales, we have to consider all things to do with designated habitats and species. Blue carbon is just one of the sort of benefits of some of those habitats. So when you're protecting the structure and function of a habitat, for example, you know, blue carbon will be one of those things you're protecting.
Okay, there's a sort of detailed question probably for Carol and Ali. This point about the comparative impacts according to the states of tides when a device may or may not be operating. One hypothesis might be that during peak tidal flows, both prey, fish, and predators, diving birds, would not be present in these particular locations, given the energy required to hunt in peak tidal flows. Is that something that is a sort of fair hypothesis that might be considered, Carol?
Yeah, I'll take that one first. That does sound like it, you know, makes very logical sense, and we have seen that in some environments where we've seen a peak in occurrence around slack tides and far less presence and behaviour and foraging at peak tides. But we have actually seen the opposite in some places, and that's the part of the problem, particularly when it comes to marine mammals. Obviously, that's where my experience lies. But so seals, for example, we've seen from a lot of UK-wide tagging studies quite a range of variation in the nature of use of tidal areas by seals. So, for example, Kyle Ray, which is a narrow channel between the mainland of Scotland and the Isle of Skye, we've seen some very, very concentrated use of the highest parts of the tidal flow by harbour seals foraging, using the hydrodynamic features that are created by by parts of the tide concentrating prey. And so, you know, that kind of critically means that risk is the theoretical worst it could be if a tidal energy project was put there. Whereas in other areas we have seen evidence that mammal activity and fish activity is the way that the question hypothesized, with far fewer fish around and fewer mammal predation activity around higher tidal flows. So I think that kind of variation between sites makes it very difficult to generalize that relationship. And we also actually have the potential that the presence of structures could also be changing the interactions between the tidal flow and the prey presence and the predator presence. And I think there is a suspicion that what we might be seeing around the Magen turbine is fish aggregation around the base of the turbine. Admittedly, that's a particular design of turbine base. And then porpoise occurrence around the base at all stages of the tide, not just at slack.
Thanks, Carol. I'm conscious we're coming up to the end, and we're going to run over about 2 or 3 minutes, because I just want to end by asking you all a question about, you know, what can we do differently? What can we do to actually address? I suppose I'm coming back to this question that Blaise Bullimore just added again. are we being too flat-footed? What crucial support is still needed to make the necessary difference? Are there things that we should be doing differently, more of, less of, here in Wales, that would really begin to move us forward and address the outstanding issues that we've talked about today in terms of the uncertainties that exist, and indeed how do we manage those uncertainties going forward? Have we got everything in place? Are there things we need to be doing more of differently? Let's see if there's any final thoughts in terms of that, and perhaps I'll end with Paul, because the innovation challenge is something that we should just sort of make sure we end with and stress. So literally 30 seconds or so each on, are there things we could be doing differently that we might be able to take forward from this session as priorities? Let's go to Jennifer first. Sorry, Jennifer.
That's okay. Yeah, I think there have been some really good points made by other speakers, so I'll maybe not say anything brand new, but I think for me, it's a really exciting time in Wales. I'm looking at it from outside. I'm based in Scotland, and I've been working mainly in Scotland for the last few years, but seeing so much momentum and energy and enthusiasm around the sector in Wales, it's really exciting to see, and support from the government, which is so vital as well, to see that being driven forward. And I think for me, I'll refer back to the point that Carol was making, and I think James was making as well, around adaptive management. These projects, there's so many projects now in Wales that I hope that they will be able to happen, and us being able to understand how we can manage them in a way that can be adaptive and move quickly to make sure that we're learning as much as we can from these opportunities. These will be small scale projects to begin with, and we need to maximize our opportunity to learn as much as we can from them, so that we can keep driving forward and building the evidence base that is specific to Wales, because there is a big evidence base out there, but there isn't a huge amount that is specific to how things are done and the specific environments and habitats in Wales. And so I think that there's such an opportunity to drive these projects forward in a way where we can learn so much from them over the coming years. And so that's the key part for me. And the other key part for me is the things I've talked about that we do as part of ORJIP, and James mentioned the Consenting Strategic Advisory Group in Wales, is to keep talking to each other, across these different types of stakeholders, coming together in forums like this through Marine Energy Wales or whatever it might be, to keep sharing the information that we're learning from each other, and talking about these issues, and putting those lessons learned into place, I think, are the really vital things that we need to do going forward.
Brilliant. Thanks very much. Important messages. Carol?
I think, James already highlighted that the approach is very collaborative, and I think that to me has been the key to where we've seen and where we've had our biggest successes. It's been through a collaborative approach between industry, government, and academia, in terms of people, the experts being able to provide the real kind of detailed technical expertise and knowledge about the monitoring technologies and the biology of the species concerned. The industry and the projects need to obviously collaborate with the monitoring and enable the technology to be deployed at their devices. And I think government need to be driving the questions that need to be answered, so that the right information is coming out to inform their decisions. And also the funding, I think, harking back to the need for resources. In Scotland, we're incredibly lucky. We've started off with the support for the demonstration strategy. And we've seen a lot of support for strategic monitoring at key projects to help move the industry forward. And I think that kind of tripartite approach has been absolutely key to the successes we've seen.
Yeah, important we learn from that experience in Scotland. Carol, thank you so much for that and for your contribution. And then we'll go to Aly, then to James, and we'll finish off with Paul, just sort of briefly if you can, because we're just overrunning slightly. So Aly?
Yeah, just talking about the uncertainty and how we resolve the amount of uncertainty. I think our goal shouldn't necessarily to remove the uncertainty from the whole process, because that's impossible, but our goal should be to quantify it and understand it. And a key way of getting a handle on that will be to incorporate more biological reality into our modelling processes. And finally, I just completely agree with Carol about the collaborative approach. That is the way that we we will we will understand and deal with the uncertainty.
Yeah, good message. Thank you, Aly, and again, thanks for the work you do and the presentation you've made. And then where are we, James, and then Paul?
Okay, yeah, just very quickly. I mean, echo what the others have said in terms of collaboration. We're doing our best to work collaboratively across the sector and with the NGOs and developers as well. I think from NRW's point of view, we've just created the Offshore Renewable Energy Programme, which has increased our resource quite substantially in terms of being able to advise on these kind of projects, but also that in terms of producing pieces of guidance to help take people through the process more efficiently, so that they don't have to ask so many questions and they can see, you know, the direction of travel and everything. And then in terms of evidence as well, it's exactly the same, that we've identified key evidence gaps that we're hoping to address. And if we can't deal with them in-house, we're working collaboratively with other organisations to try and deliver them. So things are progressing a lot more quickly now, I think, and as soon as devices are in the water, I think we're going to be in a much better position to be able to, you know, move things forward. So yeah.
Brilliant, thanks, James. And I realise you've been in a sort of bit of a focal point for the questions that have come in. If we haven't answered all the questions, we will do following the session, just to reassure people we will answer the questions you've put in, but we'll do that following the session. James, thank you. You have been in the spotlight there for much of that, so thank you very much for the contribution and to recognise the progress I think that NRW have made and invested in this in terms of building capacity. So that's an important point. And Paul, finally, coming back to you, because I think this is an important, the Innovation Challenge was an important sort of part of the message of today.
Yeah, okay, thanks, Peter. 2 points to make. First is that it won't be Catapult coming up with solutions to any of the issues we've discussed. That will come from innovators, from academia, but what we can do is we can put those ideas together, we can demonstrate them, and we can cover some of the cost of that. And if we can't cover all of the cost, we'll find other ways of doing it. That's what Catapult's all about. We're supposed to be enabling innovation to come to market, and we're supposed to be solving market failures. And this kind of environmental lack of information is a clear market failure. And just to come on to that, I mean, it's clear what we need is knowledge. And knowledge is based on information, and information is based on data. But let's not get confused about data. Data's not enough. In fact, we may already have data out there that hasn't yet been turned into information and knowledge for us to act on. There are, for instance, terabytes of video data, if you like, out there. But what do you do with it? And what can you learn from it? And until we turn that data into information and knowledge that can actually be acted on, it's simply not enough. So, you know, as well as thinking about your clever new sensor that can pick up some more information out in the sea, it's worth thinking about the data that we've got already and whether we can do more with it.
Thank you, Paul, and thank you all for your contributions. Just a final thought from me. I'm sure that message about collaboration is going to be important. I think the message about speed and accelerating our work is also going to be important. I think probably the collaboration needs to also make sure we include those communities and I guess particularly the coastal communities that are engaged around this. That's why organisations like the Pembrokeshire Coastal Forum are so important. So a big thank you to Marine Energy Wales, obviously, for hosting this session and the collaboration that it represents with over 100 attendees from all over the world. You know, Wales is in a really important position in terms of taking a lead in developing marine energy capacity, given our location and potential in terms of tidal range and tidal stream, as well as wave. So Marine Energy Wales have a key role to play. The collaboration is a key part of that work. So a big thank you to the team there who've helped to put this together today. And a final thank you to all the contributors thanks for your excellent contributions and presentations, which will be shared following and made available following the seminar, which has been recorded and so will be made available. Just to finish, Bethan, is there anything that I haven't summarized that needs to be highlighted in terms of the follow-up?
No, I think that's it. We've made a note of everybody's questions, so apologies if we haven't got to them today, but we will try to answer them via email following this. The recordings and the presentations, as well as some of the links to the key resources, will also be shared with all attendees. So hopefully we've covered anything, but if anybody does want to send any additional questions over to the MEW team, please do so. I'll put our email in the chat now.
Brilliant. Okay, in which case, thank you all very much, and have a good rest of the day, and look forward to following up on this really critical agenda. Thank you.
Thanks, Peter.
Thank you.
Thank you very much, Peter, for hosting.
Thanks now then.
All our
Thank you all.
panelists. Bye. Bye.
Thanks, everybody.